Hi, we're going to be talking about section 3.1 today, solving systems of equations. I apologize in advance, this is going to be a big video. There's just a ton with this section, so get ready to rock here. We're going to be covering systems, solving systems with tables, with graphs. We're going to classify systems. We're going to solve them with substitution and elimination, and we're going to take a look at what systems look like that have no solutions, and ones that have infinite solutions and how to identify them. Okay, we've got the system of equations we're trying to solve with the table. So a system of equations is where two lines meet. So we're trying to find the one point where two lines meet. The easiest way to do this with a table is to switch both equations to the form y equals mx plus b, so we can just plug in and solve that way. So I'm going to do that. The first equation, if I move that 2x over and then divide by -5, I should get y. Oh, let me move that back up. Y, and I'm going to call that y1, just because it's the first equation. Y1 equals, let's see, -2 divided by -5 is 0.4x, and then 11 divided by -5 is minus 2.2. Okay, the second equation, y2 equals, if I add 3x to both sides and divide by 4, let's see, 3x divided by 4 would be 0.75x. Okay, and then -13 divided by 4 is -3.25. Okay, so then I make a table and I go, I've got my x values, my y1s I need, and my y2. So I'm going to find out where do these two intersect. So I'm just going to start at 0. It's a nice place to start and see if we can follow some patterns, maybe make it faster. But the easiest way is just plug it in at first. So if I plug in 0 for x and y1, well, that gives me my y-intercept, which is -2.2 for the first one and -3.25 for the second one. Okay, if I move in the positive direction and I go on to 1, let's see what happens. This has a slope of 0.4. That means as you go over 1, it should go up by 0.4. So if I add 0.4 to 2.2, I'm going to get -1.8. If you don't believe me, just plug it into that equation, you'll get that. For the second one, we have a slope of 0.75. So that's, again, as we go over 1, that's going up 0.75. So -3.25 plus 0.75, that's -2.5. Okay, those got closer, so we're going to keep going in that direction. If those two numbers got further apart from each other, then we would need to go the other direction. So I'd go to like -1, -2, and so on. But we're going to keep going. So I go on to 2. Again, I add the 0.4 because that's the slope. So this gives me -1.4, -2.5 plus 0.75. That slope would be -1.75. Okay, and then I go on to 3. So we're getting even closer. This gives me a -1 when I add 0.4. This one gives me a -1. So I've gotten there on the table. I know this is the point. So at 3, -1, this is the point where these two lines meet. So that's how you do this using a table. So go ahead and hit pause. You're going to want to change this into y equals mx plus b, just so you can make the table, find the patterns a little bit easier. Go ahead and hit pause and find out where do these two lines intersect. Okay. Again, this first one, if you were to solve it for y, and I'll do this one slowly maybe, just so you can see if you were confused on how I got to slope-intercept form. This one we have a positive 4x, so I need to move that over, so I go -4x, -4x. Okay, I'm going to kind of rearrange the right side, so 3y, because that -4x and the 4x cancel, equals, I'm going to write the -4x first, -17. Okay, then I need to divide by 3, divide everything here by 3. Okay, I'm going to have to keep this one in terms of fractions. So I know a lot of you don't like that, but we're going to have to. I'm going to call this y1 equals negative 4/3 x minus 17 over 3. Okay. Again, if you hate fractions, you could change them to an estimate, but this doesn't have an exact value. Whenever you're dividing by 3, you're going to get that, unless it's a, perfectly divisible. It's usually going to be a 1/3 or a 2/3. So you have, 0.3 is not the same as 0.3 forever. So I like to just leave it as the fraction. Okay, for the second one, do the same thing. Move that 7 over. So we get negative 2y equals 7x plus 20 divided by negative 2 divided by negative 2. So y2 equals, and I'll change these to decimals for you because I know you like them better. 7 divided by negative 2 is negative 3.5 x minus 20 divided by negative 2 is negative 10. Okay, so if I make my table here, I go x is x or y1 and y2. Okay, then I go, okay, plug in my 0. My y-intercept's basically here. So I'm going to get negative 17/3. So this is probably where it's okay to write it as a decimal, just so you can see what it looks like. So that's going to be negative 5.6 repeating. Okay, and for the second one, I'm at negative 10. As I go on to 1, let's see what happens if I get closer or further away. If I plug in negative 1 there, that's going to be going down by 4/3. So I do, that one's going to go right to negative 7. Okay, and then if let's see, I have a slope of negative 3.5. So that's going to take me to negative 13.5. Okay, those two are further away than the other two numbers were, so we went the wrong direction. So we need to go into the negatives. We're going to go negative 1 now. Okay, so just plug that into the y1 equation. That might be the easiest way. I do negative 4 divided by 3 times negative 1 minus 17 divided by 3 equals, and I get negative 4.3 repeating. Okay, on the second equation, I do negative 3.5 times negative 1 minus 10, and I get, well, I got the wrong answer because I typed it in wrong. Let me fix where I put this decimal. Negative 6.5, so that did get closer, so we're getting closer there. I go to negative 2, and I plug negative 2 into the first equation. I go negative 4 divided by 3 times negative 2 minus 17 divided by 3. That gives me a negative 3. And then if I do the negative 3.5 times negative 2 minus 10, I also get negative 3. So that is my answer through a table. I'm at the point negative 2 comma negative 3. This is the point where these two lines meet. Okay, slow, tedious tables. Imagine if it was a number like, what if they didn't meet till they were at 100? How long that would have taken. So it worked, but kind of slow and tedious. Let's try a different method like graphing. So if we were going to graph these are maybe a little bit quicker to graph because it's in standard form, so we can graph quickly standard form. We know 4x plus 3y equals 12 is standard form, so if I'm trying to find my x-intercept, the y's go away, so I just have 4x equals 12, because on my x-axis y is equal to 0. So plug that in, you get x equals 3. So if I draw that x-intercept right there, okay, and my y-intercept for the first line will just be 3y equals 12, so y equals 4. So I come up here to 4, and I draw the best line that I can that crosses. Oh, that was bad. Sorry, see if I can get a better one here. Okay, on a piece of paper it's easier with a straight edge. Sorry, this is just hard on an iPad. For the second equation, if I plug in, find my x-intercepts, I get negative 6x equals negative 1, so x must equal, let's see, I divide both sides by negative 6, divide by negative 6, so x equals 1/6. Ooh, that's ugly. So I've got a point right there at 1/6, and then I go, okay, my y-intercept would be 4y equals negative 1, so divide by 4, y equals negative 1/4. Well, that doesn't really give me a very good line to draw there, but I know it's going to be something like that. So if I was to guess, it looks like the two lines cross up here, but that, again, that's just really hard to see. So you can already see it's really hard to find where the two lines cross by graphing. All right. If you did a better job of drawing these two, they should really hit at 1.5 and at 2. But you can already see the disadvantage of trying to see where these meet, because if I was to guess, it looks to me like they cross at 1, 2. So you can see the disadvantage to graphing. But go ahead and give this next one a shot. You'll see this one actually, because the numbers are bigger, turns out, I think, nicer on your graph. So go ahead and hit pause and give this a shot. Okay, first, we need x-intercepts. We go 8x equals 36. So divide by 8, x equals 4. My y-intercept would be negative 3y equals 36. Divide by negative 3, divide by negative 3. Y equals negative 12. Uh-oh, that means I need to change these y values. I need to change these y coordinates here. That they need to change to, let's see, the other one I'm going to get y equals negative 21. So each dash would have to be 3. So the way that it's labeled right now, let's change this to, let's get rid of that, and let's go all the way up here. If each one's 3, that's 3 times 7 is 21. Let's get rid of that one there, go down here to negative 21. My x's, let's see, the 4 is fine, 21 divided by 6, that's fine. So my x-axis is fine. Alright, so I'm at negative 12, let's see, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it was negative 12, wrong direction, sorry. We'll go blue. That's 3, 6, 9, negative 12. And this is 4. Connect those two dots with a line. Okay, for the second equation, if I go 6x equals negative 21, divide by 6, divide by 6, I can divide both of those by 3 and get negative 7 over 2. So that's my x-intercept. So that would be negative 7 over 2 is negative 3.5. So that's right there. My y-intercept, if I plug in a 0 for x, I just get y equals negative 21. So that's down there. I connect those two dots. Okay. It looks like they cross right there. So if I was to guess with this one, I would say that looks like they cross at negative 1, comma, let's see, negative 15. That would be my guess. The actual answer for this one is really ugly. It's negative 27/26, comma, negative 192/13. So you can see this is graphing definitely has its disadvantages. Classifying systems. Okay, a consistent system has at least, so let's use a change to, it says a system with one, it should say at least one solution. At least one solution. That's a consistent solution. So you could have a parabola and a line that cross, that has two. Okay, you could have two lines that cross, that's where those two cross. You could have, a line that crosses 3 times. Those are all consistent because there's at least one solution. All right. An inconsistent system is a system with no solutions. To get no solutions, all right, let's look at this, maybe this red line and this blue line. Okay, those two don't touch. They're parallel, meaning they have the same slope and they have different y-intercepts. So that would be an inconsistent system. An independent system is a system with exactly one solution. So that's just talking about this example here where we have two lines that cross each other. Okay, so this is not independent, this is not independent because they have multiple places that they cross. And this one's not either because it has no solutions. Versus a dependent one would be like, if we were talking about this red line again, and we have a black or another red line right on top of that. Or like I was about to say, a black line right on top of that. That's the same line, same solution, so they would have infinite solutions, which is different than all real numbers. Not all real numbers, but there's an infinite number of places that those lines touch because they're the same line. Okay, so really the easiest way to look with lines, okay, we're never going to get a line to hit the other line more than once. It doesn't work with lines. So we're going to be specifically focusing on that. We're not going to have this situation where we have a parabola right now or a cubic function. We're just talking about two lines. So do they have the same slope? We need to basically find out. And do they have, if they do have the same slope, do they have the same y-intercept or do they have different y-intercepts? If they have the same slope with different y-intercepts, they never touch. If they have the same slope with the same y-intercept, they always touch, meaning there's infinite solutions. So if we look at this first example, in my opinion, the easiest way is just to solve for y, put it into point slope, so we get negative 4y equals negative 6x plus 15. So I just moved that 6 over by making it negative on the other side, and then divide by negative 4, divide by negative 4, so we get y equals negative 3 halves x minus 15 over 4. Okay, the second line would give us a 4y equals 6x plus 18. Okay. Oh, sorry, this one over the first one, a negative divided by negative is a positive. That should be a positive 3 halves. So if I divide by 4, I get y equals 3 halves x plus 18 over 4 is 9 over 2. Okay, so both of those have a slope of 3 halves. So they are the same slope, but they have different y-intercepts. Because they have the same slope with different y-intercepts, they never touch. So that's an inconsistent system of equations because there's no solution. Okay, why don't you try this one? Try to put it in slope-intercept form and then decide, is it consistent, inconsistent, independent, or dependent? Okay, hopefully you got these two equations. So we can say that they have different slopes. Because they have different slopes, we know they can't be parallel or the same line. So we know that this is a consistent solution that is independent, meaning it has at least one solution, but even more specifically, it is exactly one solution. So I would classify this one, just the most specific it would need to be to say this one's independent. Okay, solving systems with substitution. So substituting, we need to have y or x equal to something. So if you see in this example, we don't have it down to that, but if you look at that second equation, there's no coefficient in front of y, meaning there's no number in front of y. So if we could just move that 2x over, it's solved for y, and we can substitute that then in place of the y in the first equation. So let's move that 2x over. So we would subtract by 2x. So I'm going to get y equals 7 minus 2x. Okay, the second equation, all right, this part in blue, we have 5x, so 5, minus 3. Okay, I'm going to put the y as red. 3y equals 23. Now, I know that since this is equal to y, I can substitute in place of that y 7 minus 2x. So I'm going to do that. 5x minus 3, and then we have, instead of y, we have the parentheses 7 minus 2x. That's what y is equal to, equals 23. Okay, so now we use the distributive property and distribute that negative 3 to both of these. So we get 5x, negative 3 times 7 is negative 21, negative 3 times negative 2x is positive 6x equals 23. Okay, I need to combine my x's together and get that negative 21 over to the other side, so I'm going to add 21 to both sides. So those cancel. I have 11 x's on the left equals 44 on the right. Divide both sides by 11, x equals 4. Okay, well, remember that a system of equations is the point where the two lines meet. So we only have the x part of the point. We need the y part of the point. So go back to your y equation here and plug in place of x. Substitute in that 4. So y equals 7 minus 2, and then we know x is now 4, so 2 times 4. 2 times 4 is 8, so y equals negative 1. So now I have the point where these two lines meet, 4 comma negative 1. Now one of the best parts about solving systems is you can check your answer so easily. We just want to take this top equation now and plug back into it the 4 and the negative 1. So is 5 times 4 minus 3 times negative 1 equal to 23? Well, 5 times 4 is 20. Negative 3 times negative 1 is a plus 3. That is equal to 23. So check, we're good to go. Okay, go ahead and hit the pause button and give this problem a shot. All right, hopefully you solved both sides for x. Solved for x. So you move that. You added 7y to both sides. So we get x equals 11 plus 7y. Okay, and then you take that and you put it in place of the y this time. Now you may have done it the other way. You may have solved the second equation for y, and that's fine. I bet we come up with the same answer as long as you did it right. So I'm going to do this 5 times, I know x is equal to 11 plus 7y plus y equals negative 23. Okay, from here I'm going to move everything up a little so I can use more space. So that's 11 times 5 is 55 plus 5 times 7 is 35y plus y equals negative 23. Okay, I need to move that 55 over, so subtract it to both sides. That's 36 equals negative 78. Okay, I hope that wasn't 36y, sorry. Divide both sides by 36, and we get y equals, let's see, you can divide 78 and 36 by 6, so you get a negative 13 over 6. Okay, I'm going to plug that into this x equation right here. So I get x equals 11 plus 7 times negative 13 over 6. So x equals 11 plus, let's see, 7 times negative 13 is negative 91 over 6. Okay, then I need to change to 11 to have a denominator of 6. So 11 times 6 is 66 over 6 plus negative 91 over 6, which gives me negative 25 over 6. So this is an ugly one, but negative 25 over 6 comma, where'd my y value go? There it is, negative 13 over 6. Okay, check that with the second equation I plug in. Let's see, 5 times negative 25 divided by 6 plus negative 13 divided by 6, is that equal to negative 23? Yes, it is. Check, check, move on. Okay, sorry I gave you guys an ugly one with fractions. I thought the numbers were going to end up nicer than that. Okay, so that was solving a system of equations with substitution. Unfortunately, we're not always going to have a nice easy equation that we can set so that we have x equals or y equals. And these would be really ugly to get them there. So instead of doing that, there's another method called elimination. And the goal is to line up all your x's and y's and your 1's, and then to be able to add the equations to each other so that when you add them, and the reason that's legal is we're saying that by saying that these two sides are equal, if we add this 4x minus 3y to this side and add the negative 22 to this side, remember in algebra, as long as you add the same thing to both sides, it's legal. Well, this equal sign says that adding those to both sides would be legal because they're equal to each other. So we're adding the same thing to both sides. That's basically what that says. So there's the legality of what we're doing. So what we need to do, and the goal is to eliminate one of the variables. So if the coefficients in front of either variable are the same but opposite, and we add them, like for this example, they're already the same but opposite in sign. If we add these equations up, we'd get 6x, the y's cancel, equals negative 6. So I know x is equal to negative 1. And then I can plug that into either equation. I'll just do the top one. 4 times negative 1 minus 3y equals negative 22. So that's negative 4 minus 3y equals negative 22. Add 4 to both sides. Negative 3y equals negative 18. Divided by negative 3, divided by negative 3, y equals 6. So this point is at negative 1, oops, not in parentheses, negative 1, comma, 6. To test that, 2 times negative 1 is negative 2, 3 times 6 is 18, negative 2 plus 18 does equal 16. So there's my check. Okay. So I want you to try with this next one, but notice you're going to have to try to do something a little bit different because even though the coefficients are the same, they are not opposite in sign. So give it a shot, go. Okay. One way you could have done it is you could have subtracted the two. Now, I see more mistakes in people subtracting negative numbers in math than I see anywhere else. So I would not recommend that. I would always multiply one of the equations by negative 1 to get them the same but opposite in sign. Because right now we have a negative 5y and a negative 5y. So if I take that top row and I just multiply everything by negative 1, I'm going to get negative 6x plus 5y equals 8. Okay. By doing that, now I have them to where if I add them, they'll cancel. And I'm not going to have to worry about subtracting by any negatives. So I always recommend doing that. That's the only way I'm going to teach it because I see so many fewer mistakes by doing it this way. Okay, 4x plus negative 6x is negative 2x equals negative 12 plus 8 is negative 4. So x equals 2. Plug that into either equation. I'll just use the top one. 6 times 2 minus 5y equals negative 8. Okay, that's 12 minus 5y equals negative 8. Minus 12, negative 5y equals negative 20. I know that negative 5 times 4 is negative 20, so y equals 4. So my answer is 2, 4. Okay, I'll check that. 4 times 2 is 6. 5 times 4 is 20. 4 times 2 is 8. 8 minus 20 is negative 12. Check, check. There's your right answer. Okay, if we were solving this problem, this would be set up for a elimination problem. So let's just do that. Let's take this. I need the coefficients to be the same but opposite. So I'm going to multiply, to try to get my x's to cancel, I'm going to multiply this by a negative 3 because negative 3 times 2 will give me negative 6. X, and that will give my x's, or that will cancel my x's. So that would be negative 6x. Okay, negative 3 times times 3y is negative 9y equals negative 3 times 5 is negative 15. Okay, now if we add these up, negative 6x plus 6x, those cancel. 9y plus negative 9y, those cancel, so I have 0 equals 15 plus negative 15 is also 0. Okay, so we've gotten to a point where all of our variables have canceled. So now is where I always ask myself a question. Whatever I have left, I need to say, is it true? When is 0 equal to 0? Always. 0 is always equal to 0. Therefore, when do these two lines meet? They always meet, which means there's an infinite number of solutions. Okay, infinite number of solutions. That does not mean all real numbers. It just means these two lines are the exact same line. Okay, go ahead and hit pause and see what you get with the next line. Go. Okay, this one's harder because if you're trying to multiply by something to get these two things to be the same, we really have to multiply by two different numbers. So if we took this top equation and multiplied it by 3, took this bottom equation and multiplied it by 2, then my y's will cancel. Notice I just took the coefficient in front of the y's on the bottom and multiplied that to the top equation, took the coefficient in front of the top y and multiplied that by the second equation. So 3 times 4x is, we'll write it just next to it, 12x plus 6y equals 6. Second one, 2 times negative 6 is negative 12x. 2 times negative 3y is negative 6y equals 2 times 3 is 6. Okay, when I add them this time, I'm still going to get a 0 on the left, but 6 plus 6 is equal to 12 on the right. Okay, so when is 0 equal to 12? Never. 0 is never equal to 12. Therefore, when do these lines touch each other? They never touch each other. So this one would be no solutions. That's how in math we write no solutions, a little O with a line through it or a 0 with a line through it. Okay, bring in lots of questions. That was huge. Sorry for the big long video, but that was a big one.